Hi and welcome back. This is section 2 of the video where we'll discuss about Kubernetes architecture and learn what happens when we try to deploy deploy the pod using kubectl command. So this slide we already saw, right? So what actually we want to do? We want to create a deployment. We want to create the replicas of that deployment. That is, we want to scale that deployment with 3 replicas and then expose that deployment using the service to port 80 and finally use curl command to access that service IP. So we want to know what happens if we run the following commands. We are interested in learning more about each step that occur in the deployment phase. Let's start by discussing what really happens. When we write a command using kubectl, it generates a manifest describing a deployment. That manifest is sent to Kubernetes API, where the API server validates the manifest and asks etcd to process the command. Controller inside kubectl manager wakes up and do a bunch of stuff in our case, adding the replica set and parts to the etcd database. The scheduler wakes up and assigns the available nodes to the pods based on the resource availability, taints and tolerations defined in the definition of YAML definition file and some other factors. Kubelet sees that a pod is assigned to it and runs the pod on the node. And after that, we'll set kubeproxy and try to know that what problems it solves. Let's start by analyzing what are the alternatives way of accessing the API server. Do we only have to access the API server using kubectl command, or can we access the API server using curl, because that's the REST API, right? And REST API can be called using curl, Postman, or Go client, or Java, or Python, or any languages, right? So let's see if that's possible or not. So I have found a good link here, and I'll just copy this link and let's visit this link. So we have different alternatives of accessing the cluster using the Kubernetes API, and one of them is using kubectl command, right? So, but what are we are here to see the alternative. So one alternative is, if you want to use the curl, you can use kubectl as proxy and proxy to port 8080 and then use curl command and you'll see the output. So this is one of the way that we can do it. Another way is like if we don't want to use kubectl, then we actually have to set up some cluster information like the cluster name, the API server where it is, and the token, service account, and all that information. Let me show you what are the information that is needed. Okay, so we need a server API server this URL, that is the DNS name. By default, it is called as kubernetes.default.service. That is the internal service server host name. We need a path to service token. We need pod's namespace, that is in which pod we want to run this curl API. We want to know the service account. We want to know the we should have the location of the CA, and finally we should have the token. So using this, we can actually now curl the API, that is /API server, and we'll get some output as such. And we can perform other operations too. Okay, so but we have other options too, like if we want to use Go client, like if we are building some website or something on Go, and we want to use our Kubernetes API server, so we can do it. There is an easy way to do that, and here it is provided in the documentation. We can in fact use Python for, like, there is a package I think in Kubernetes that is Kubernetes package is there, from where we can import the client and configuration and work with that. That's really easy. We have Java client and we have .NET client, JavaScript client. So because API server is a REST API, we can access it using any language of our choice and also use curl command to access it. The only thing is we should know that how to access it. And this documentation will really help you understand how we can access without using kubectl. Next, we are going to visualize the workflow using few slides that I have got from a Lisa website. And let me show you the website from where I received that. So it's actually a great source of information, and this was Lisa 19, that is 2019 conference from where I got this. And you can search here Kubernetes and you'll get that deep dive into Kubernetes, and here you'll see the video, and this is the original author of that means original person who created that slide, and here you can see his original video. This is the slide that I got from Listen 19 website, and this was a tutorial on YouTube available. There was a talk on YouTube available. So let's see how this actually works. So we have a client, right? That client that can be a service or that can be a user. So a user writes kubectl run web dash image equals to nginx and replica equals to 3. That is he wants to create an nginx image with 3 replicas. He makes a communication with API server. kubectl communicate with API server. API server on the other hand communicates with etcd and add that deployment to the etcd distributed database. After adding, etcd responds back to API server, and then API server responds back to the user that okay, your deployment.app/web created, but it is not actually created. It is just added in the etcd store and nothing else has happened till yet. Next, control manager is looking to the etcd cluster, that is keeping a watch on the etcd cluster, and it sees that okay, we have a deployment. It communicates with API server and says API server that hey API server, create a replica set. etcd API server tells etcd to add replica set, and then etcd responds back and adds a replica set. Next, control manager sees the replica set and asks API server to create pods. So control manager asks API server to create pods, and API server says etcd, hey etcd create pods, and etcd creates a pod and marks its states as pending. Till now there was a communication, till now we saw that there is a communication between API server, etcd and control manager. Next comes the task of scheduler. As soon as the pods are marked as pending, scheduler watches that state and sees that oh okay, now do I have any nodes available? Means any nodes are registered to the API server. If yes, schedulers assign that nodes to the pod. We have 2 nodes, node 1 and node 2. Schedulers ask API server to assign that nodes to pod, and that node is selected based on the resource availability and other factors. Next comes the task of kubelet. Kubelet sees that okay, I have a pod to run. Means kubelets of particular node sees that I have a pod to run. It creates a pod on the node and then says back to API server, hey, I have created the pod. API server talks to etcd and says that hey, pod is created, and etcd marks that pod as running. So this was a flow of how control plane components and worker node components communicate with each other. We have not seen kubeproxy in action, but we'll see it later in the demo.